Welcome back, Precalculus. We're on to number 14. 14, I see r is equal to 2 plus 4 sine theta. Anytime I see a plus or minus, what are we thinking? We are thinking we have a limison. This would be 2 divided by 4, which is 1/2. We can go back up to our chart. 1/2 is going to be that very first one, right? When we are less than 1. So we're expecting to come up with a limison with an inner loop. So we want to write limison with an inner loop. All right, is it going to be symmetrical about the polar axis or about theta over 2 or pi over 2? Because it's a sine theta, it's going to be theta is equal to pi over 2. To find our maximum r values, again, sine theta oscillates between -1 and 1. So when we're at -1, that means we've got 2 plus 4 times -1. This is going to be -4 plus 2, which is -2. And that would be when is sine -1. That is when theta is equal to, sine is -1 at 3 pi over 2. When are we at 1? Well, at 1, we would be 2 plus 4 times 1. 4 plus 2 would be 6. And we are at 1 when sine theta is equal to pi over 2. So our maximum r value is going to be at 6 at theta equals pi over 2. This point here is going to become important too, as you'll see in just a second. The next thing we want to find is our zeros. This is so much nicer than that lovely rows up above, right? So we're going to solve this equation. Subtracting 2, I get 4 sine theta is equal to -2. Sine theta would be -2 divided by 4, which is -1/2. When is theta equal to -1/2? Sorry, when is sine theta equal to -1/2? That would be at 7 pi over 6. Remember when I told you that unit circle was important? And 11 pi over 6. Sorry, that is 7 pi over 6. Kind of hard to read that one. So our zeros are at 7 pi over 6 and 11 pi over 6. Now this is going to have an inner loop to it. We know our maximum value is at pi over 2. We're going to be out at 6. So pi over 2, we're going to be way up here. At 3 pi over 2, we're at -2. So when we're here, we're going to be at -2, and that's going to be the maximum height of my inner loop. And then these zeros kind of define how far out we go. So I'm going to draw little things, and this is just something I do. It's not really part of the graph. It's just something I do to help guide how our graph looks. So we have an inner loop that's going to go like this, and then kind of goes below. Oh, cannot graph on this tablet. Outer look, kind of something like that. So it's going to dip below the polar axis there just for a minute. Oh, just pretend like your teacher can actually draw. All right, that's our limison with an inner loop. I know you're probably freaking out because these are hard, and normally we'd have a long time to kind of soak this in, and we go a little slower. Don't worry, please don't stress out too much. I want you to be able to identify like the orientation of it. When you do the IXL math, that's kind of the level that I'm going to test you on. I'm not going to be asking you to do a whole bunch with this. So try not to stress out. I know this is hard stuff. I want you to watch me and I want you to take notes on how to graph these in case you ever do have to graph them by hand. But for the most part, for this test, it's not going to be this challenging, I promise. All right, that's it for number 14. I'm going to put number 15 on the next video.